Okay, to conclude question 2.3.1, now we have identified that the hexane here means that you have 6 carbons in the parent chain, and the compound is an ane, meaning that there's saturation. Okay, now going to the branches now. By the way, this is a haloalkane. So what happens in a haloalkane is you number the carbons. Carbon number 1 is going to be the one closest to the haloalkane. In this case, the position of the haloalkane is 3. So the fluorines are going to be in carbon number 1, 2, 3. So I've put 2 fluorines there because it's difluoro in carbon number 3. Then in the next carbon number 4, there is the ethyl group. Ethyl, eth means 2. Therefore, meaning that our branch has 2 carbons. Carbon number 1 and carbon number 2. Can we see that? Yes. So this is an ethyl branch, and it occurs in carbon number 4. And how to mark that? 1 mark goes to the correct positioning of the 2 fluorines in carbon number 3, the correct positioning of the ethyl group in carbon number 4, and the correct structure will give you the 3rd mark. So you have 3 marks for that. Yes. Now, let's go to the next question there. Now, the general formula, it wants the general formula of the homologous series to which compound E belongs. Okay, let me just erase this. We don't need this for now. Okay, so we are in question number 2,3,3. 2,3,3. And we want the general formula, compound E. By the way, compound E, we've identified it as an alkene. It's an alkene. And we know that the general formula of an alkene is CnH2n. Because if the hydrocarbon is saturated, if it's an alkane, it becomes CnH2n plus 2. Now, the alkene is such that for the same number of carbons, you have 2 less hydrogens. Hence, you have 2n. So if you have 2n plus 2 and you remove 2, you are left with 2n. Can you see that? You are left with 2n. So this one here has 2 less hydrogens. Then for alkynes, the general formula there is going to be Cn, then 2 less. So if I am at 2n and I subtract 2, then I am going to be having what? H2n minus 2. Alkanes, alkenes, and alkynes. Yes. Okay. Then, next question. structural formula for the functional group of compound F. Okay, I have compound F. We have identified it as, it's compound F. Compound F there is a ketone because you can see the carbonyl right in the middle. Right in the middle there. So the structural formula for the functional group, functional group, the ketone. You are going to show that you have a carbonyl connection there. So the functional group, the structure is going to, then you're going to have other two carbons there. You can either leave it as C, but do not complete with OH, because now it won't be a functional group anymore. Or you can just leave it as the carbonyl in the middle, then represent the chain ka arga mole le chain ye arga. So this is that functional group, and it gives you 1 mark, or that to give you 1 mark. Okay, then 2.3.5 IUPAC's name of the alcohol needed to produce compound B. Okay, compound B, the structure of compound B. Let me go get it from the compound B is this one here. And we see that this comes from the carboxylic acid, and this comes from the alcohol. So it comes from an alcohol with 1 carbon, which is methanol. So the answer to that one there is methanol, a 1 carbon alcohol. Yes.